So in today's video of this series, we're going to go over our custom XML-like parser for our coding agent. So basically what this function does, it takes the response from the LLM. For example, this could be an example response, and then extracts the tool call that the LLM wanted to use. So if this was our example response from the LLM, and we call the parse tool call function on this string, ideally what we want from this function is going to return a dictionary, and the key of this dictionary is going to be the name of the tool that this agent wanted to use. In our example, the agent wanted to use the read file tool with the parameter path, which is set to source/main.js, and the value of the return dictionary is going to be another dictionary that represents the parameters and their values for this particular tool call. Now let's look at the implementation of this function. First, we initialize some variables to keep track of some values. For example, the name of the tool that's being used, start and end indices for the tool body, and also the dictionary to store the parameter names and their values. After that, we enter our first loop, where we go over the list of all the available tools. In the tool names variable, we have a list of all the available tools for our agent. We go over each of the tool names one by one and check whether their corresponding opening tag is present in the response body. For example, for the tool name read file, the opening tag is going to be read file enclosed with angle brackets. If we do find the opening tag in the LLM response, now we need to find the closing tag. If the closing tag is also found, that means the end index is not -1. So that means that we found both the opening tag and the closing tag for this tool. And now we need to extract the body of the tool call so that we can pass the parameters and their values. So for that, the tool body start index is going to be the start index where we found the opening tag for this tool plus the length of the opening tag. So this is the start index plus the length of the opening tag is going to be the start of the tool body. And the end index of the tool body is going to be the end index where we find the closing tag, which is here. And then we break out of the loop. If it didn't find any tags for our existing tool names, then we just return an empty dictionary. And now we extract the tool body from the LLM response, starting from the start index and end index that we defined earlier. And now we're about to enter our next loop, which iterates character by character in the tool body and passes the parameters and their values. Inside the loop, we go over each of our existing parameter names. Similar to the tool names, we also have a list of all the available parameter names. And so we go over each of those parameters and check whether the current position of the tool body starts with the opening tag for this parameter. If it does, then we need to extract the value for this parameter. So we define the start index where the value starts as the current position, which is here, because this is the position where we found the opening tag for this parameter path. So the current position plus the length of the opening tag for this parameter. So this is where the value starts for this parameter, which is the parameter value start index. So after finding the opening tag, we also need to find the closing tag to see if it's valid or not. So now we handle one special case where the name of the tool is write to file and the parameter is content. So inside of the content that the agent is trying to write to a file, there could be the content tag itself inside the content. So to tackle the situation, instead of just finding the closing tag, we use rfind to find the last position of the closing tag so that we can extract the maximum value for the parameter without any error. But apart from that, we just use the general find method to find the closing tag for that parameter. So if we find the index of the closing tag for the parameter, for example, this is going to be the parameter value end index. So the value of this parameter is going to be from parameter value start index till parameter value end index, which is this one for our example. So after extracting the value, we just save that value in our parameters dictionary, which we're going to be using at the end to return the value. So now we need to update the current position so that we can move on to passing the next parameter. We want the current position to be the end of the closing tag for the parameter that we just extracted. So we set the current position to be the index of the closing tag of the current parameter, which is here, plus the length of the closing tag. So effectively, the current position is now at the end here. So if we were to have more parameters like this, the current position will start passing the next parameters. If for some reason we don't find the closing tag for the parameter, This could be, for example, the LLM might use invalid formatting for the XML. So we just ignore it and set the current position to the start of the parameter value. So for example, if we didn't have the ending tag, we want to continue parsing from here. So we set the current position to the parameter value start index, which points here. And if we didn't find the opening tag for any of the existing parameters in this iteration, then we just increment the current position so that we can move on parsing to the next character. And at the end, we just return a dictionary where the key is the name of the tool that we found and the value is the parameters dictionary. So we get our desired output like this. So that was it for today's video. So in the next video, we're going to discuss what tools are necessary for a good AI coding agent.